Hello, it's me, Krishna Pokhrel. I'm here to prepare a short video regarding a phase shift oscillator, how to perform an experiment of phase shift oscillator. Here we need this operational amplifier. I already told about this phase shift oscillator, um, about this operational amplifier. Sorry, I didn't told about the phase shift oscillator before. About this operational amplifier, how to connect it, I have already described it in my previous video of uh, that wind bridge oscillator. We have a 741 ICs needed, which have 4 terminal, 1, 2, 3, 4. Okay, 1, 2, 3, 4. The numberings will be done by this way. There is a little bit black dot mark. If we keep like this, then from here 1, 2, 3, 4, and from here 5, 6, 7, 8. 5, 6, 7, 8. By this way, we can number that legs of such IC. And what we need to do is we'll supply 12 volt, positive 12 volt to the 7 number point, and minus 12 volt to the 4 number point. And this positive terminal will be ground. Okay, positive terminal will be ground, and this from here we'll start making a circuit. We'll connect 3 capacitor in a series, and we'll connect 2 resistance in a parallel, whatever this value, but the value will be same. Okay, we can change this value later on, because whatever the value of capacitor here, it should be same, because the notation is same, that is CCC RRR. Here this resistance, one resistance will be in series, and the 2 resistance will be in parallel. In book we may see this resistance in parallel, but it do not give a correct data. So for this we need to keep this resistance in a series. So and it is same like that wind bridge oscillator. And here what we can do is we need to connect one variable resistance potentiometer. We have which have 3 legs. I already told about this in my previous video of wind bridge. Here we need to connect this variable resistance RF, and it will be connected to the output of this operational amplifier. This output is number 6. So now, as mentioned here, we can connect this. This capacitor will be taken 0.1 microfarad for a correct reading. It gives a correct reading. The IC number is 104. Oh, sorry, capacitor number is 104. This all 3 resistor of 0.1 microfarad. Code number 104 should be connected here. And this R we can keep 1 kilo ohm. Okay, at first we need to change this data and see the voltage input and voltage output curve. We can check voltage input from here by connecting with the oscilloscope, and voltage output we can check from here or anywhere where we like, from the 6 number terminal. Okay. From here we can connect voltage output, and from here we can connect voltage input. So now here it is a phase shift oscillator. Its gain is -29. Why the number, the sign minus is over here? The sign minus refers that it is out of phase. Out of phase means if the input voltage can be seen like this, then the output voltage will be like this. It is out of phase. Whenever we see here, its crest is here and its trough is here, just out of phase. So this is the theoretical gain of this amplifier. How to calculate the experimental gain? By how much we can get the gain? We need to calculate the voltage output. We need to calculate voltage input, and we know the formula for gain, that is BO by B in. B output by B input. By this way, we can calculate this voltage. Okay, I hope I made it clear. B input. By that way, we need to calculate for 3 different value for resistance. One time we can keep a resistance 1 kilo ohm, all these 3 resistance. Another time we can keep 2.2. Another time we can keep this resistance value 3.3. It's better to change the resistance than capacitor, because if we change capacitor in my experiment, I didn't get such type of reliable results. So you may try by changing capacitor. If you get the gain 29, then it's correct. And the theoretical frequency, we need to trace a curve for these 3 values of voltage input and voltage output, and we need to see whether it is the gain is minus 29 or not. This negative is shown by this one, and it is 29 times or not. We can calculate from our oscilloscope. And we know the theoretical value of frequency is 1 by 2 pi RC multiplied by root over 6. Whatever value of R is kept for 1 kilo ohm, we take out one frequency. That frequency should be equal with the experimental frequency. How to calculate experimental frequency? If we have a output curve, suppose this curve is for volt output, this waveform, then we need to check from here to here what is the time period of this wave. That time period, if you divide it by 1, then we can get a frequency. From this we can get experimental frequency. From here we can get theoretical frequency. So we compare it. If we have little bit changes, then we can calculate some error if needed. So by this way, this experiment is performed. And after that, there are some precautions to perform this. Adjust potentiometer for a good waveform. We need to adjust this potentiometer. It is kept over here. Potentiometer should be kept in such a way to get a good waveform. And RF by R should not be less than 29. Should not be less than 20. If you divide RF by R, then the value should not be less than 29 because its gain is 29. It can be more than 29. Suppose if you give here 100, we can keep here 1, 2.2, 3.3, because if we divide, we get value more than 29. So it is a thing to be understood. And take capacitor of 0.1 microfarad 104, that is the code 104. It gives a very good result. Okay, up to by saying this much, I would like to end my few words regarding the phase shift oscillator. Okay, here one thing I want to say that we'll not take voltage input from this 3 number terminal because it is ground. We do not get any kind of voltage over here, so we'll take voltage input from here. Okay, so if you have any kind of doubts, then you can contact to me. Those who are listening this video, okay, I definitely I shared this video to some of my friends, those who really need it. Okay, thank you very much.